All right. So I've looked for many, many years, Gabriel, to find the perfect sheet that allows you to understand Vesper and to be able to utilize it as a resource. And I found it. There's only one small, little bitty, tiny issue with it, but it should not be a problem. Remember yesterday we kept talking about the A-B model? This sheet is perfect other than instead of B, they used X. So when I say B, you just need to look at the X. Okay? That's the only thing wrong with this entire sheet. So if you want to make that little note where it says AX, just say that's the AB, or AB is AX. Okay? So I want to walk you through a few of these things because we're going to start drawing our first Lewis structure today. Okay? So when we begin to draw them, what you're going to have to do is determine the AB model. Then, once you've determined it, you can use this sheet to give you the information you need, such as bond angle, such as shape name, such as hybridization. But I'm going to teach you how to do all of that without this sheet. But by the time we're finished with it, you will be able to rattle them off like you know your name and your ABCs. Okay? I know that you think I'm crazy, but just like when I talk electron configuration, you thought I was crazy when I said you'll be able to do it by the end, or are you able to? Most of you. Some of you. Yeah. Same thing here. Some of you with this, because you're not putting the effort into it. Okay, but I promise you it will become more understandable as we go. So I'm not going to spend a whole lot of time on this, but as we go back and forth drawing, I will address this and show you how to use it. Okay? So the next thing I want to look at is this right here. So everybody find this sheet right here. Okay? This is going to be your guide, step by step, of exactly how to draw Lewis structures. Okay? Every year I've tried to refine this and make it as best as possible so you don't have to think about what it says. I found one little place earlier where you got to add just like 8 words to clear something up, but it's all going to make sense. Okay? So let's start with number 1. So as we do this, I want you to practice drawing with me one of the examples just on the back. So we're going to flip back and forth as we go. All right, so the first thing we have to do is list each element and how many of each of them are present. So let me pull this up. Let me go right here. So what we're going to do is if you'll just flip your sheet of paper over and write this formula, CH4. Okay? This is one of the most basic chemical compounds on the face of the planet. Does anybody happen to know what this is? It's methane. It's what? Methane. What is methane found in? Cow flatulence.
Yeah, that was just right there.
Okay? Everyone know what flatulence is, correct?
No.
If you don't know, look it up. I'm not telling you. I don't want your mother mad at me. So, again, reread step number 1.
Never mind.
List each element and how many are present. Did I list each element? Now we've got to determine how many are each. So this is very simple. Just look at the formula. How many carbons are present? 1. How many hydrogens are present? Does everyone understand that? Is that self-explanatory? Yes. Okay. Let's read step number 2. Number 2. Determine the number of valence electrons for each element. Well, how in the world are you supposed to know that? Keep reading. Valence number is the group number. So you're going to need your periodic table for this. Okay? So carbon, what group number is it in? 14, so it has how many valence? 4. Hydrogen is in group 1, so it's got 1 valence, right? Now, so here's where I need you to add something. Okay? What we got to do in step 3 is, here's what I have to add. We've got to determine the total number of electrons for that compound. Well, I did not include how you do that. So this is the only thing you're going to have to write on this. Okay? By multiplying the total number plus valence number. That's supposed to be plural, by multiplying. Sorry, I forgot the ing. That's not grammatically correct. My apologies. By multiplying the total number plus the valence number. And this will make sense as soon as you see it. So all we're looking at right now is step number 3. So we've determined the number of valence. Now we need to determine the total number of electrons for that compound. Okay? If you're still writing, I promise I'm going to come back and you can keep going. But flip it over for right now. So did I multiply these two numbers together? So what is 1 times 4? 4. What is 4 times 1?
1. Oh.
4. Now, what is 4 plus 4? 8. So I have 8 total electrons. So in this molecule, CH4, there's a total of 8 valence electrons that we've got to deal with. Okay? Now, I want to go back and read parts 3, A, and B. So let's keep reading. Remember, if it's charged, so I'm going to stop right there. Is this molecule charged? Yes or no? How can you tell? The way you can tell is there a plus or minus on it? There isn't. So do I even need to worry about that? Nope. So let's go to 3B. Be sure it's not an odd number. Is 8 an odd number? So we're good. But why can't it be odd? Electrons come in pairs. What is a pair? 2. All right? So far we good. All right, so let's go to step 4. Step 4. Everybody good on the red words? Okay. All right, let me clear. Scroll up. Number 4. Draw the skeleton structure. And I know that sounds weird, but the more you see this, the more you'll do it. It will make complete sense. How do you do it? You determine the central atom. Everybody circle that word right there. The central, or if you have a highlighter, you can highlight it. Now I know what your question is. How are you supposed to know what the central atom is? I'm going to tell you the rule, and then I'm going to give you a tip and trick. Here's the rule. It's the atom with the most available domains. What was a domain? You read it twice yesterday. Very good. It's an attachment point. So for our molecule, carbon had how many valence electrons? 4. How many does it need? 8. So how many empty spots does it have? 4. So does it have 4 domains? Okay. The other word I want you to highlight or circle is the word most. Okay. Hydrogen. Hydrogen has how many valence electrons? Be very careful with this answer. How many does it want? 2. Very good. So how many empty spots does it have? 1. So which one had more? Carbon had 4, hydrogen had 1. So who had more? Carbon. So who's in the center? Carbon. Let me give you the tip and trick. Carbon is in the center when? Always. Who's never in the center? That's the tip and trick. Okay? So we're going to work this out. It'll make more sense. So we're going to put who in the center again? Carbon's going to go in the center. Everybody okay so far? Again, the more we do this, the better you'll get at it. Number 5. Connect all the other elements to the central atom with a what? What does a line represent? A bond. So here's what we're going to do. We're going to connect them up. How many do I have to connect? 4. I'm going to ask this question. It's very important. All 4 hydrogens want to be as close together or as far apart as possible. As far apart. So I'm going to draw them like this. Does that make sense? Any questions, any issues so far? Yes, ma'am. Are they as far apart as possible? Then that's how you draw it. Okay. Now, we're going to have to come back to that question, but just keep that in mind. Okay. Now, let's go down to 5A. Subtract the number of bonded electrons from the total. What was our total number? 8. Of electrons already calculated. And this is the important part. One line is how many electrons? 2. So come back over. How many lines do I have? 4. So how many electrons do I have? 8. So 8 minus 8 is what? 0. I'm out of electrons. They're all gone. They're all done. Does that make sense? So let's keep reading just in case we don't have to do anything else. Step number 6. Give all outer atoms a full octet. Now, there's two questions to that. Do I have any electrons left? So I don't have any more to give. But why don't I need any more? Hydrogen only needs how many? Do they all have 2? So we're good. I don't even need to worry about that step. I can skip it. Step number 7. Put all of the extra electron pairs. Do I have any left? Skip it. Number 8. If the central atom is not yet surrounded by 4 electron pairs or 8 total, let's pause and check. Who's in the center? Does it have its 8? So do I even need to worry about that step? Skip it. Put a big star beside number 9. This is the most important step. Okay? 2 electrons. Now, 1 line is 1 bond, and 1 bond is 2 electrons. Okay? So, we're going to use VSEPR. Circle this word right here. Okay? That is the sheet you have. We're going to talk about it. To determine the molecular shape and draw the correct representation. So what we've got to do is we've got to come back and we've got to look at this shape. And we've got to ask ourselves, is it the correct shape according to VSEPR? So before we do that, I want to ask you a question. Can you determine the AB model of this molecule? Okay. Who's the A? Carbon. Who are the B's? How many B's? So write AB4 on this below this. Okay? AB4. So now let's come back and address this. Now, again, I told you the only problem with this sheet is that instead of it being a B, what letter is it? It's an X. So find AX4 on this sheet. Right here. So here's the question. What is the name of that shape? Tetrahedral. Write that down. This is tetrahedral. And again, the way you know that is that every AB4 molecule is what shape? Tetrahedral. What is the bond angle of this shape? 109.5. Write that down. But then the final question you have to ask yourself is this. Is it drawn correctly? It's not. And let's talk about why. What dimension have I drawn this on the board? 2D. Molecules exist as what? 3D. On the board currently in 2 dimensions, what's the bond angle between all those H's? 90. Now in 2 dimensions, is that as far apart as you can get them? Yes. But in the 3rd dimension, is there more space to work with? Yes. So can they actually get more than 90 degrees apart? You just wrote that number down. How far apart are they actually? 109.5. Does this molecule represent that shape? Yes. On the board, does this molecule represent that shape? It does. So what you've got to do is I want you to draw this again, but we've got to adjust it. So if I'm in the 3rd dimension, instead of it being out like a cross or like a T, what do I do with my arms? I push them down. Okay? Now, are they still actually pointing straight down? No, they're kind of kicked back at an angle, right? So this is how we draw it. So what we do is we put our C in the center, we put our H on top, we put our H on the bottom, and then what do we do with our side arms? Bend them down. So this is what I was expressing to you yesterday. In the 2-dimensional world, are they as far apart as possible? No. But in the 3-dimensional world, are they? Because how do you have to picture that drawing in your mind? The bottom one is coming out of the board at you, right? And the 2 that are down at angles, what are they doing? They're kind of kicked back into the board away from you. Okay? So that is the correct shape for this molecule. Does this make sense? Okay? All right. So now let's keep doing this, but I have beat myself over the head trying to find this sheet right here, and I can't find it anywhere. So I'm just going to have to use the whiteboard and draw it along with you guys. Again, I apologize, but I cannot find it in any of my files. So find the side with H1 on it. Or not H1, HI. Okay? So the first one we're going to do is HI. So here's what we're going to do. We're going to do the molecule. We're going to do the Lewis structure. But look at the next set of columns that are kind of a tandem columns. It says bonded to the what atom? Circle that word or put a star beside it. Again, at the very, very top. Bonded to which atom? Central atom. Okay? And it wants to know the atoms bonded to it, and then the unshared pairs bonded to it. So what letter represents the atoms in this case? B. That's your B. Right? A, B model. What does the unshared pairs represent? The E, the lone pairs. So that is going to give you your AB model. Does that kind of make sense? Because can there only be one in the center? So A is always one, right? We're going to do the shape of the molecule. Where are you going to get the shape from? That other sheet, right? Where are you going to get the bond angle from? That other sheet. Hybridization. Don't do anything in that column today. I'm going to come back and teach that to you later when you feel comfortable. How many of you like drawing flowers? You're going to love hybridization. If you don't like drawing flowers, you're still going to love hybridization. Okay? Then we're also going to talk about polarity as well. So today, hybridization will stay empty. We'll come back to it. All right, so let's do HI. Let's follow the rules. What's the first rule? Wesley, read it out loud. And I'm going to snake the room for this. Wesley, read number 1. Loud as possible.
List each element and how many there are present from the formula.
All right, so who are the two? Everybody. Hydrogen and, oh, let's try that again. Hydrogen and iodine. How many of each are present?
1.
1 each. That's real hard. All right, Anthony, read number 2 very loud, please. How do you know the valence number? Keep reading. All right, so what group is hydrogen in?
1.
So it's got 1 valence. What group number is iodine in?
17.
17, so it's got
7.
7. All right, Jacob R., read the next one. Number 3, please.
Determine the second number of electrons for that compound on which point the second number is plus the valence number.
Very good. So what's 1 times 1, everyone?
1.
What's 1 times 7?
7.
What's 1 plus 7?
8.
8. Jacob R., please read 3B. Actually, read 3A first.
Remember if it's charged.
Pause. Is it charged?
No.
How can you tell?
There's no positive.
There's no positive or negative, so do you even need to worry about that?
No.
Skip it. 3B.
Be sure it's not odd.
Is 8 odd?
No.
Nope, we're good to go. All right, Caroline, please read 4 for me. How? Keep going. Pause. Is one of these not allowed in the center? Who? So automatically, who's in the middle? Iodine. Okay? So iodine. Thank you, Caroline. All right, Jonah. Read 5 for me, please, sir. Who's the only other thing over there? Hydrogen. So I'm going to connect it. Silly question. Doesn't matter. Does it matter what side H goes on? Doesn't care at all. If you want to put it on the left, put it on the left. If you want to put it on the right, put it on the right. I don't care. Doesn't matter at all. Jonah, please read number 4A. Excuse me, 5A, sorry. All right, so how many was our total number already calculated? 8. How many have I used so far?
2.
Jonah, read what's in parentheses under 5A. Does that make sense to everybody? So what am I going to subtract from 8?
2.
So what is 8 minus 2?
6.
Now, I'm saying this out loud, and this is very important. Yes, you need to do the math. And when we start doing more complex problems, you will see why you need to do the math. It will always fix your problem. The math will fix your problems. Okay? All right. Oscar, please read 6A.
Give all outer atoms a full octet.
Now, here's the problem. Who's in the center of this?
Iodine.
Iodine. So it says give the outer ones any. But Oscar, read the parentheses of that same line.
Except hydrogen.
Someone tell me why hydrogen doesn't need any more. It only needs 2. Does it have its 2? So I got to skip this one, right? I can't do it. Okay, Jacob N., please read number 7.
Will all the extra electron pairs on the central atom?
This is important. How many extra electrons do I currently have?
6.
How many pair is that?
3.
3. So I'm going to put 3 pair around the iodine. 1, 2, 3, 4, 5, 6. So how many did I just use? All right, Jacob Reed, is it 7A? Am I out? So 6 minus 6 is I'm out of electrons. Okay? All right, Colin, please read 8.
If the central atom is not yet surrounded by 4 electron pairs.
Pulse. Is the central atom surrounded by 8 electrons? How can you tell? There's 6 dots and then 1 line. But what is 1 line? 2. Very good. So is it okay? So does it have its octet? All right, now this is the most important part, so I can skip 8. So Karen, please read 9.
That was fun.
Using this to determine the molecular shape and correct representation.
All right, so let's be very honest with ourselves. Do I really need to adjust that in any way, shape, form, or fashion? You really can't, right? But let's just follow the rules. So, in the next column, how many atoms are bonded to the center one? 1. So that's going to be 1. This is very important because it's going to be a little tricky. How many extra pairs are on the central atom? 3. So the model is A, B, E, 3. Now, I'm asking you to do something that's going to waste your time. Find that on the front side of the sheet that you have, the best prepared sheet. The reason it's going to waste your time is because you're not going to find it. The reason why is because that shape can only be one thing. What is it? Linear. That's it. Remember how I said yesterday, any diatomic molecule. What does diatomic mean? 2 atoms. How many atoms are there? It's got to be what shape? Linear. Automatic. Okay? So this is linear. The shape name is linear. If it's linear, the bond angle automatically has to be what number?
180 degrees.
You got that, right? Very, very simple. Everybody cool with this? Now again, we said we're going to skip hybridization for today, but next is polarity. So, first of all, are these 2 sharing electrons? Is this a molecule is my question.
Yeah.
Peanut butter goes to jelly as molecule goes to covalent. Is this a covalent bond? So it's a molecule, right? So my next question is, what causes polarity? And I actually want you to write this above where it says polarity of molecules. What causes it?
Differences in electronegativity.
Very good.
Yay!
Differences in E-neg. That causes polarity. Okay, differences in E-neg. So let's come back up here and look at this. Actually, wrong button. Is one of those more electronegative than the other?
Yes.
Yes. Now remember how you did the worksheet the other day where you actually had to calculate the difference and look on that scale and tell where it was? Now I don't remember the exact numbers. I think this was it. Iodine was 2.7. Hydrogen was 2.1. So what's the difference? 0.6. Does anybody remember what the value was and below for non-polar? It was 0.3 and below. Is this 0.3 and below? No, so this is polar. So what that means is this. Is this dot being shared between those 2? So is this occurring? But because iodine's more electronegative, what happens to this electron? Who does it spend more time around? So does this occur? And then it comes back over here every once in a while and spends time over here, and then this occurs, right? Does that make sense? So because this is polar, which end is partially negative? Left or right? This is partially negative. This is partially positive. Don't draw the circles, just the pink. That's all I want you to draw is the pink. I'm just explaining why it's polar. The purple, not the blue. All I want you to draw is the pinky purple stuff. In the molecular shape. So pink, what color is that to you, Caroline? What color is that? I'll answer your question. Pinky purple, magenta, done, period. Draw that magenta color in the lowest structure box. What?
Where drew that?
Exactly. She didn't.
Oh, okay. I thought you were asking.
Oh, the what? The CH4.
I thought that same thing.
She's talking about polarity.
Polarity and polar. Yeah,
Oh,
okay,
it's
no, it's polar. Yeah, polar goes in the last box. Yeah.
That's all you had to say.
I went over that for real.
Is that same?
Yeah.
Okay.
I thought it was supposed to have to draw
So let's go to the next one. CBr4. That's wrong. Let's try this again. CBr4. Okay? All right, Carolyn. So read me step 1, please, ma'am. Yep.
List each element and how many of each are present.
All right, so who are the 2 elements, Carolyn? And how many carbons are there? 1. How many bromines are there? Everybody cool so far? Now, by the way, and I should have said this, I apologize. I do want you to do this, I know there's not a lot of room, and I do apologize, but out to the left side, or you can do it out to the right side, write this math down. I do want you to write this down. So if you didn't do it on the last one, you need to go back and do it. So let me go back and do this. Go back, and if you didn't write down, if you did not do that, somewhere out to the left or somewhere out to the right, please write those numbers down, because I'm telling you, if you don't do the math, you're going to make a mistake, and I can always come back to this and show you where your mistake was. It's mind-boggling how the math actually leads you to the mistake. So just what's in the left of that blue box. Okay, please, please, please make sure you get this math. Everybody good? Sir?
Can I write in that molecule box?
No, please don't. Well, okay, if you can cram it in there, that's fine. If you can cram it in, that's fine. All right, so now let's go back to this, and let's keep going. Ayana, please read step number 2.
Determine the number of valence electrons.
Okay, Ayana, how many valence electrons are there for carbon?
4.
4. Ayana, how many for bromine? 7. All right, everybody, what's 1 times 4? 4. What's 4 times 7? 28. And what's 28 plus 4? 32. All right, Anna, please read 2B. Sorry, never mind. Emily, read 3 because we've already done it. All right, have we done that? Read 3A. Pause. Is this thing charged, everyone? How can you tell? There's no positive or negative. All right, Emily, read 3B for me. Is 32 odd?
No.
So we're good to go. All right, so let's keep going. All right, Gavin, read step 4. Keep going. All right, so here's the deal. I've got carbon and bromine. Now, we can do it the long way and use the definition, or I gave you a tip and trick. Is one of these always in the center? Which one? Carbon. So carbon's always in the center. All right? So carbon's in the center. All right, Gavin, read, never mind, next, Gabriel, read 5, please.
Connect all the other elements to the central atoms of the line.
All right, so how many and what am I going to connect to carbon? Gabriel? What and how many am I going to connect to carbon?
4.
4 what?
BR.
BRs. Important question to everyone. How do the BRs want to be from each other? As far apart. Now, I'm going to draw something. And some of you may want to start throwing stones at me, and that's okay. But I'm going to do it this way, this time, and I want you to start catching what I'm doing so you don't do it. And I'm going to walk you through it. Again, I'm not going to do it every time, but these first few times I am. All right, so, Lillian. No, excuse me, we're still on Gabriel. Gabriel, read 5A, please, sir.
Subtract all the subtract the number of bonded electrons from the total number of electrons. Always calculate one line equals to
All right, so how many's already calculated? What's our total? Gabriel, what's our total calculation so far?
Our code 32.
32. So how many do I need to subtract from 32?
8.
Why is it 8?
Because there's
4
4 bonds.
bonds means how many electrons?
8.
8. Where do you think a mistake may occur right here?
People think it's on 4 electrons.
Very good. So it's got to be 8. So 32 minus 8 is how many? 24. All right, so I've got 24 electrons left. Lillian, please read 6 for me.
Give all the outer atoms.
Pause. Who are the outer atoms? Bromines. Okay, keep reading.
Except hydrogen. Subtract the number
Well,
of
go back. Give the outer atoms what? A full octet. Except who? Do I even need to deal with hydrogen? No. So I got to give each bromine an octet. How many electrons does each bromine already currently have? So they each need how many more? 6. So how do I give it 6? Dots. So I give 3 pair of dots to each one of them. All right, Lillian, please read 6A.
Subtract the number of off-campus electrons and remaining electrons.
All right, what's the remaining electrons available? 24. Now, how many did I just use? Now, what's one long way you can determine it? You can count them all, right? Or you can say each one of them got 6, and there are 4 of them, so 6 times 4 is? So I'm out. Does that make sense? Okay. All right. So, Mackenzie, please read number 7 for me.
Include all of the extra electron pairs in the central atom.
Do I have any more electron pairs? So can I do that step? Skip it. Katerina, number 8, please. Pause. Look at carbon. Does it have 8?
Yep.
Yes. How can you tell?
Any bond is
It's got
2.
4 bonds, and 1 bond is 2 electrons, so 4 times 2 is 8. So do I need to worry about that step? All right, let's keep going. All right, Gina, read number 9. And again, this is the most important step.
Using Vester, determine the molecular shape and geometry representation.
All right, so here's what we're going to do. Let's go to the next column. According to the central atom, how many bonded atoms are there? 4. So put a 4 in that first column. According to the central atom, how many lone pair are on it? The central atom, 0. Again, the key word there is the central atom is 0. So what is your AB model? Write that somewhere in those boxes. You can write it between the two if you want. Now consult your Vesper theory sheet. Okay, consult your Vesper theory sheet. And the interesting part is, I think I actually already have this perfect. Again, it's AX4. What is the shape name? Tetrahedral. What is the bond angle?
109.5.
109.5. All right, but let's go ahead and let's talk about the shape. On the test, if you draw it like a cross, like I have it currently drawn, is it right or is it wrong? It's wrong. What do we have to do to that 90-degree angle? Squeeze it down. So outside of this box, on the right-hand side of the sheet of paper, okay, if you want to draw it below or out to the right, redraw this the correct way. Okay? So how you're going to have to draw this is C, 1 BR up, 1 BR down, and then 2 BRs down at angles, and each of them having 6 dots around it. So the goal of this process is, by the time you get to Monday, you don't have to redraw it. You draw it straight up the right way every time. Because practice makes perfect on these things. Okay? Now, the last question is the most important question, because it takes a little bit of thinking. Does that molecule on the board look like the one that's in my hand? Okay? Yes. So, if those BRs, these red little spheres, are trying to pull that black one closest to it, which one's going to win? None of them. Therefore, if all of the forces pulling in the opposite directions cancel out, then what is the polarity? Non-polar. That part is probably the trickiest, but you have to just look at them over and over and over again, and it will eventually begin to click. All right, so let me do one more for you, and then I'm going to let you practice one. So go down 1, and it's H2S. All right, Antonio, please read number 1 for me, please, sir. All right, Antonio, who are the elements? All right, how many hydrogens are there? How many sulfurs are there? Very good. Jamia, read number 2 for me, please, ma'am. All right, Jamia, how many are there for hydrogen? How many for sulfur? 6. Very good. Why is it 6? It's group 16. Fantastic. All right. Next, Destiny, read number 3 for me, please, ma'am. Okay, so help me do this math. What's 2 times 1?
2.
Destiny?
Oh.
2. What's 1 times 6, Destiny? What's 2 plus 6? 8. Thank you. Also, read 3A for me, please, ma'am. Pause. Is that thing charged? How can y'all tell it's not? It's no positive or negative. Okay. Also, Destiny, read 3B for me. Is 8 an odd number? No. Very good. Okay. All right. Wesley, back up here to you. Please read number 4. How do you draw the skeleton structure? Keep her going.
Determine the central atom.
All right. So you can do the rule and you can go the long way, or you can know the trick. Is one of these not in the center?
Yes.
Who? Hydrogen. So what does that mean? Sulfur's in the middle. Okay. So I gotta put sulfur in the center. Okay. Anthony, please read number 5 for me.
Connect all the other elements to the central atom of life.
All right. Who am I going to hook up to S? Hydrogens. How do the hydrogens want to be to each other? So I'm going to ask a dumb question. Is that appropriate? No. Is that appropriate? No. Is that appropriate? Yes.
I mean, either way.
Is that appropriate? So the point is, could you draw it vertical or horizontal? Doesn't really matter. Let's be honest, how are we probably going to draw it? Horizontal. So that's how I'm going to draw it. So I'm going to put it horizontally. Again, it does not matter, but typically we see things horizontally versus vertical. Okay? All right. Anthony, please read 5A.
Subtract the number of bonded electrons from total numbers.
All right. What's the total number we've already calculated?
4.
Anthony. What's the total number we've already calculated? 8. How many do I need to subtract? Anthony. Thank you. What is 8 minus 4, Anthony? 4. So I've got 4 left. All right, Jacob R. Read 6. Pause. Who are the outer atoms? Jacob R. Hydrogen. Thank you. Keep reading. Do I need to give hydrogen any electrons? Jacob R. Do I need to give any? Keep reading. What does it say? Nope, nope, nope. Go back to 6 and read the whole thing. Except who? They're right there in front of you, right? Why don't I need to give hydrogen any? That's for everyone. It's already got its full octet, right? It's got its 2. Now, octet is arbitrary, but it's got its 2. Now, so, Caroline, number 7.
Put all of the extra electron pairs on the central atom.
Now, this is important. The electron what? Pairs. How many total do I have left? So how many pairs do I have, everyone? 2. Now, I'm going to go ahead and tell you something. We're going to have, so let me actually, before I draw this. If you've already drawn something, I hate to ask you to do this, but erase it. Take the box that we're drawing this in and cut it in half of the line and draw this above the line. And you'll see why in just a second. I should have told you this before you did it. That's my fault. Please don't hate me. Again, take that box, draw it in a line, and cut it in half. That's why you shouldn't write in pen. Okay? So, what you guys told me to do was to do this. Now, have I just used all 4? I'm out. I'm out. So, Jonah, please read number 8 for me, please, sir. Pause. Is sulfur surrounded by 8? Yes. So do I need to worry about that? Nope. So let's keep going. All right, Oscar, please read number 9.
Using Vesper, determine the molecular shape and draw the correct representation.
All right, so let's go to our Vesper. So let's go to the next column. According to the central atom, how many atoms are bonded to it? 2. According to the central atom, how many lone pair are around? 2. So what is your AB model?
AB2.
AB2, E2. Write that down between those boxes. AB2, E2. So now consult your VSEPR theory sheet. And everybody find AB2, E2. All right. So what shape does that correlate to? Bent. What bond angle does that correlate to? 104.5. But now, we've got to figure something out because the shape may not be quite right. So let's come back and let's look at the shape. Actually, let me pull this back up. So this little molecule in my hand, is that what's on the board? No. How can I turn this into that? You got to take 2 out. Now, you told me, pause. What shape does it look like? It looks linear, but you just wrote what? Does that look bent? Yes. That doesn't look bent? Looks pretty bent. This looks bent. So you have to draw your molecule like it's bent, and here's why. You remember this yesterday we did on the Hogan. Those electron pairs, do they take up more space, the same space, or less space than an atom? More space. So what do they do to those hydrogens sticking out to the side? Push them down. Okay? So this is how you have to draw this. Okay? So underneath that box, or wherever you have space, that's not right. Let's try this again. It's an S with like 2 little antennae or alien eyes, and your H's are bent downwards. Again, you cannot draw this molecule like a line. And it should be self-explanatory. You just told me the shape was what? Bent. You can't say it's bent and then draw it straight. That does not correlate. It's got to be bent. Does that make sense? All right. Everybody good? So what I want you guys to do is try the bottom one. Skip HCN, and you'll see why, but skip HCN and try the bottom one by yourself.
Oh, okay.
All right, who do we leave off with?
HCN is the last.
Oscar, you went, didn't you? Did you go on the last one? Did you go on the last one? No, we're going to start with you. Oscar, number 1. Please read number 1. All right, so who's the elements, Oscar? Who are the elements? How many of each are present? Very good. All right. Jacob N. Number 2. Okay. How many valence electrons for carbon?
4.
How many for chlorine? 7. Colin, number 3.
Determine the total number of electrons for the compound.
All right. Help me with some math. 1 times 4 is?
4.
4 times 7 is?
28.
4 plus 28 is?
32.
Thank you. All right. Read 3A for me.
Remember if it's charged.
Pause. Is this charged?
No.
How can you tell?
No plus.
No positive or negative. Is 3B?
Be sure it's not an odd number.
Is it an odd number? Nope. Very good. Okay. Karen, number 4.
Draw the skeleton structure.
Who's going to go in the center of this thing, and how do you know? Why? Always in the center. Okay. All right. Carolyn, number 5.
Number 5 is connect all the other elements to the central atom with a line.
All right. So what elements and how many do I need to connect? 4. And who are they? Carolyn. Chlorine. All right. Now, so let me ask you something.
This whole class.
Do you agree that that is 2-dimensionally as far apart as possible? Yes, but we don't draw 2D. How do we draw? 3D. So I need to change this. So I'm going to go ahead and realize and recognize that I don't need to make it like a cross. I don't need to make it like a T. I need to make it bent down like it's kind of possibly maybe going to be a tetrahedral. If there is a change, we'll adjust later. But let's just run it like we have it. So I've got to put my chlorine, 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 chlorine. Okay? Ida, please read number 6. Actually, check. Go back to Carolyn. 5A, please, ma'am.
5A. Subtract the number of bond.
Yeah, that's a typo. Just scratch out ED on numbered, please. 5A, subtract the number. Scratch off the ED.
Subtract the number of bond electrons from the total number of electrons actually calculated.
Already calculated. What's your total calculation already? 32. So how much am I going to subtract from 32? Keep reading. In the parentheses. How many lines do you have? So how many electrons do you have? 32 minus is?
Are you talking to me?
Yes, ma'am. 24.
Sorry.
Okay. Now, Anna, please read number 6.
Give all outer atoms a equal octet.
Except, are those hydrogens? So do they need an octet? Yes. So I'm going to count them 2 at a time. How many more do each one of them need? 6 each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So what have I just done? I'm out. I'm done. I'm finished. Okay? Emily, please read number 7. Do I have any left over? No, I'm out, right? So I've got to skip that one. Gavin, please read number 8. Pause. Is the central atom surrounded by 8 total electrons? Do I need to do anything else there? Skip it. All right. Gabriel, number 9, please.
Using VESPER to determine the molecular shape and draw the correct representation.
All right. So let's do VESPER. Okay. So let's go to the next 2 columns. How many atoms are bonded to the central? 4. How many? Be very careful with this answer. How many lone pair are around the central atom?
0.
None. So what's the AB model for this? AB4. So go to your VESPER theory sheet. What shape is AB4? Tetrahedral. Is that the correct structure for tetrahedral? Yes. That's how it has to look. What's the bond angle? 109.5. Mackenzie, yes ma'am.
Number 9, right?
Yes ma'am.
It says the lone pair.
Yes ma'am. Okay. Do you see any dots around the central atom? Then it's 0. Let me give you an example. If I have 2 left over from this, I have to stick those 2 in the middle. Is that a lone pair? Then it would be 4 and 1. Let's pretend that I had 4 left over. I'd have to stick 2 more over here, right? That would be 4 and 2.
Okay, so wait, I have a question. Okay, so each of the 2 dots, like.
That's 1 pair.
Okay.
It's a pair of dots, right? You wear a pair of shoes, pair of dots. It comes in pairs. Okay? Karen,
How do you determine polarity?
that's next. So the next question we have to discuss is polarity. Are those chlorines pulling on that carbon? Yes. Why? It's more electronegative. So do you agree that all of these chlorines are trying to pull that carbon towards itself?
Yes.
So the question then becomes is, which chlorine would win?
None of them.
None of them. Does that molecule look like what's in my hand?
Yes.
So if those red things started pulling on the black, will any of them win? No. So if none of them win, if all of the charges in the opposite direction are all canceling each other out, then what kind of molecule is it? Non-polar. Joe, does that answer that question for you? Yes, ma'am. Say that one more time. Yep, and there's some left over. Is that? Yep. Good question. Let's do the next one. That's going to answer that question. Yes, sir.
So like
Don't be confused.
when like people like scientists people talk about like unstable molecules,
Yep.
would those be like non-polar or polar? Like the ones that are just like
That wouldn't exist at all. Unstable wouldn't exist.
it's so like that reacts to studies. Like what's like
All right, so let's go back up and let's do the third one, or actually it was the fourth one, HCN. So I'm going to tell you, this is the one that is going to challenge you to use every single rule. Okay, it's the first one we've done that we've got to use every single rule. So let's follow along and make sure we get it just right. All right, Lillian, you're up first. Read number 1, please, ma'am.
List the element and how many of each.
All right, so this time we've got 3. Who are they? How many of each are present? 1 each. All right. Mackenzie, read step 2, please, ma'am. All right, so how many valence electrons are there for hydrogen? 1. Mackenzie, carbon. 4. Mackenzie, nitrogen. All right. Number 3, step 3, Katarina, please, ma'am. All right, help me do some math. What's 1 times 1? 1 times 4? 1 times 5? Total, Katarina? 10. Read 3A for me, please, ma'am. Yes, ma'am. Pause. Is that charged? How can y'all tell? No positive or negative. Read 3B, please, ma'am. Is that an odd number? Let's keep going. Number 4, Gino. Who's in the center of this one? Why? It's always in the center. For this one, I actually want to do the long version. Read what's in the parentheses after that.
Atom with the most available domains.
Pause. Carbon has how many valence electrons? 4. So it has how many empty spots to get to 8? 4 empty spots. Nitrogen has how many valence electrons? 5. So it's how many empty spots to get to 8? 3. Which one is more? Carbon has 4, nitrogen has 3. That's why carbon's in the center on this one. But it's always in the center. Now, this is a question. How do the carbon, check. How do the nitrogen and hydrogen want to be from each other? It's far apart. Stupid question deserves a stupid answer. Is that correct? Is that correct? Is this correct? It's appropriate, but not the best, so what do you really want to do? Do it side by side. Now, the other question is, does it matter which side the H or the N goes on? Doesn't matter at all. You get to pick. I'm going to put the H on the left, I'm going to put the N on the right. And the reason why is because that's how the formula has it listed. Again, that's just, doesn't matter, but you can do whatever you want to do. All right, so now we got to follow our rules. All right, Antonia, please read number 5. Did we do that? Read 5A. What's the total number I have? Total. 10. Antonio, how many have I used? 4. What is 10 minus 4, Antonio? I've got 6 left. All right, Jamia, read number 6, please, ma'am. Except. So how many do I have left, Jamia? 6. Who's not getting any of them? So I've got to give all 6 to who? Nitrogen. Now, this is an important question. By putting these 6 electrons on nitrogen, what have I just given it? It's 8 valence electrons. Is it happy? Let's keep reading. Coming back up here to you, Wesley. Number 6. Or actually, did I do math? No, I didn't do math. Jamia, help me out. How many did I just use? 6 was 6 minus 6, everyone? So I'm out. Do I have any left? I'm out. Wesley, please read number 7.
Put all the extra electron pairs in the centroid.
Do I have any to give? I sure don't. This next step is the first time you've seen this one, and it's the most important. Anthony, please read number 8.
If the central atom is surrounded by 4 electron pairs.
Pause. Look at carbon in the center. How many does it currently have? 4. How many does it have to have? 8. This is important. Anthony, keep reading. Keep reading. Only carbon, nitrogen, oxygen, phosphorus, and sulfur can do this. Are we dealing with 2 elements that can do this? Yes. Carbon and nitrogen. So reread the underlined portion one more time, Anthony, please, sir.
Convert one or more terminal atom alone
So what am I going to do? I'm going to take these electrons and do what with them? I'm going to move them over, and I'm going to turn it into a what? A double bond. Now, here's the problem. How many does it have now? 6. Am I done? Can I move any more? Now, what do I do with the bottom 2? I'm going to take these, and I'm going to move it there and turn it into a triple bond. Now, someone tell me why I had to move them to get to 8. So now let's recount. Does nitrogen still have its 8? Yes. It's the 2 pairs and the 3 bonds. Does carbon now have its 8? Yes. Does that make sense? So again, what's the reason we have to move them around?
So, carbon gets 8.
Very good. Because the center molecule must have its 8 valence electrons. Now, the way I typically do this, because I want you to visually still understand it, because sometimes it doesn't make sense if you leave that there, I like to erase that, and now it makes a little more sense. That's the prettier version of it. Okay? So again, I take the dots off so they're gone. You don't double count them by accident. But that's what I did, is I just moved those dots. Now I have a follow-up question about this molecule specifically. Which end, the hydrogen carbon or the carbon nitrogen, are the bonds shorter? Which side, the single bond or the triple bonds, are shorter? Triple. Which side is weaker? Single bond, right? If I just walk you into karate class, 1 board or 3 boards, which one's easier to break? One board is weaker, right? That should make sense. So in the end, is this an appropriate molecule for Lewis structure? Now let's do our Vester theory. Okay? This is still the same answers. How many atoms are bonded to carbon? How many atoms? Do the bond numbers matter? No, just the atoms. There are 2 atoms bonded to the center. Be very careful how you answer this. How many lone pair are on the central atom? None. There are 0. So what is your AB model for this? AB2. Now let's be very honest. Is there any, what is the shape of that? It's a linear line, right? That's it. Okay? It's a line. It's linear. So as soon as you make it linear, what's the bond angle? 180. Now we got to get to polarity. Okay? Now we got to get to polarity. Is one of those ends more electronegative than the other? Which end? Nitrogen. So which direction are the electrons going to flow? From left to right or right to left? Left to right. That's the direction of the dipole. Okay? So because one end is more polar than the other, or more negative than the other, is it polar or non-polar? This is polar. This is a polar bond. Any questions? Yes, ma'am. Yes. So here's what I want you guys to do. I want you to flip over, and I want you, actually, let's do one more together. I got 12 minutes. I'm going to do one more. And then I'm going to get you, if there's any time left, you can practice some more. So flip over, and let's do PCl3. Actually, you know what? This may take more than 12 minutes. So let me start with this one tomorrow. So what I want you guys to do is flip over and do the top one and the third. So do SF2 and CH3Cl. Yes, sir. SF2 and CH3Cl. Just so those two. Again, we'll do PCl3 tomorrow. It will probably take right at 10 minutes, and I don't want to run out of time. So we'll do that first thing in the morning.